In section 5.6, we will be talking about how to prove that a quadrilateral is indeed a parallelogram. There are 5 ways in which we can do this. The first way is to show that both pairs of opposite sides of a quadrilateral are parallel. So, in the diagram, if we can prove that this side is indeed parallel to this side, and this side parallel to this side, then we can say that the figure is indeed a parallelogram. The next is to prove that both pairs of opposite sides of a quadrilateral are congruent. So in this case, what we would do is we would prove that this side congruent to this side, and then this side congruent to that side. The third is a combination of the first two. If we can establish that one pair of opposite sides are both of a quadrilateral are both parallel and congruent, then it will be a parallelogram. So in this diagram, if I can prove that this and this are parallel, and this side and this side are congruent, then the whole figure is a quadrilateral. Or we can do the other side. We can say that this side is parallel to this side, as well as being congruent, then again the whole figure. Notice that it has to be the same side, which is parallel and congruent. The fourth way is if the diagonals of a quadrilateral bisect each other. So we can draw in the diagonals here, and if we know that this is congruent to this, and this segment is congruent to this segment, we'll notice that the diagonals bisect each other. If we prove both of those, then the quadrilateral is a parallelogram. And finally, the last way that we will prove that quadrilaterals are parallelograms is if both pairs of opposite angles of a quadrilateral are congruent. So, in this case, if I can prove that this angle is congruent to that angle, and this angle congruent to this angle, then indeed the figure is a parallelogram. Let's look at the first example. If we're given the following diagram and the information that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3, we need to find a way to make this quadrilateral a parallelogram based on one of the 5 reasons that we just listed. So, looking at the diagram, I can see that angle 1 and angle 4 are congruent, but you should also notice that it's part of a transversal line XZ that cuts into line segment XW and YZ. Well, since 1 and 4 are congruent and they're alternate interior angles of a transversal, that means that WX and YZ will be parallel, which is one step closer to a property of a parallelogram. And one pretty important thing that I forgot to note in the given is that PX will be congruent to QZ. Now, we have one pair of parallel sides in the diagram. Now, there's a couple of ways that we can go about this. We can try to prove then that the opposite sides are parallel, or we can try to say that that same side that we just proved parallel is also congruent, and that will prove that the quadrilateral is a parallelogram. The easiest way to go about this, I think, will be to prove that the sides are congruent. And the way that we can do this is we can say that the triangles are congruent, WXP and YZQ, based on angle-side angle. Therefore, the sides are congruent based on corresponding parts. Therefore, WXYZ is a parallelogram because if a pair of sides are congruent and parallel, it implies the parallelogram. Let's look at example number 2 now. We know that KJZM and POYM are parallelograms. We're given that angle J is x plus 5 and angle K is 2x plus 1, and we are trying to figure out angle O. Well, What we know about parallelograms is that the angles consecutively after each other are going to be supplementary. So I can take x plus 5 plus 2x plus 1 and set that equal to 180. And then solve for x. Therefore, x equals 58. And since x is 58, we'll plug it back in, and that will mean the angle J will be 63 degrees, and angle K will be 117 degrees. Now, if we fill that into the chart, 117 degrees and 63 degrees, and we know that the other properties, that this will have to be supplemental to that, or that these two are congruent to each other, I can fill in the rest of this parallelogram pretty easily. Again, this is congruent to angle J, so this will be 63 degrees. Now, I also know that the smaller figure is also a parallelogram, so again, these will be congruent. And then O and this angle right here will be supplementary, so it's 117. Or you can go with the fact that these will be parallel, because if these are parallel, then this will be parallel. And then therefore this angle K and angle MPO right here are corresponding parts of parallel lines being congruent. So we can easily fill in the entire diagram if we just know one angle. So angle O will be 63 degrees. Let's look briefly at one of your homework problems. Number 14. If we're given that RSOT is a parallelogram, we know that MS is congruent to TP. We want to prove that MOPR is a parallelogram. Well, we have the segments marked in the diagram already, but let's look at what we can figure out from RSOT being a parallelogram. Based on that information, there's a lot of things that we can say. We can say that the opposite sides are congruent, so we can say RS is congruent to TO. We can also say that RT is congruent to SO based on the properties that opposite sides of quadrilaterals, or opposite sides of parallelograms, are congruent. Now, looking at the diagram, we see that gives us two sides out of triangles being congruent. What we can easily say now is that ST is congruent to itself, making triangle RST congruent to OTS based on side. From there, what that can do for us is that we can get this angle congruent to this angle, and what that allows us to do is to get this angle congruent to this angle, which will then make the outside triangles congruent. So again, once I get the triangles congruent, we can then say that the sides are congruent based on CPCTC. We can also say that the angle right here is congruent to this angle right here based on corresponding parts as well. And if you notice, that angle is technically an alternate interior angle of the transversal MP, which then implies that MR and OP are parallel. And once I have a parallel and congruent sides, then the figure is a parallelogram.